Hey Islanders, welcome back to another episode of How to Understand the Basics of Python, where today we're going to be talking about how to understand lists and what are they useful for. Alright, so sit back, relax with your favorite snack, and let's get started, shall we? For those Islanders that have just joined us and haven't decided to subscribe yet, I highly suggest subscribing. On this channel, I teach you robotics through machine learning and artificial intelligence. In order to understand machine learning or artificial intelligence, you really have to understand Python and what are the inner workings of Python. So I started this little series going on where talking about the basics of it, and today we're going to be talking about lists. Now, the way to think about lists, if you have any prior experience of programming, it's essentially Python's version of an array. You can actually send in more than just numbers. You can use a string array, integer array, whatever you really want. That's what you can use a list for. They're really cool for a lot of different use cases. Today's use case actually comes from a book that I've been reading called Dive into Algorithms by Bradford Tuckfield. All right. Inside of this book, there's a lot of great algorithms. But recently, in one of my computer science classes, we started talking about recursive algorithms. Inside this book, there's an algorithm called, I always mess up the name, Russian peasant multiplication. Really cool algorithm. It's another way to essentially do multiplication. So instead of knowing your full multiplication table, you can actually do something that's you can actually use this algorithm to figure out really big multiplication numbers. But inside this book, he doesn't use a recursive algorithm to do it, but I have actually changed it up to be able to use a recursive algorithm. So this video is really going to be about recursion as well as lists inside of Python. Alright, so what are we going to need? Well, why don't I just start getting the program ready while you guys sit back and just watch this high speed of me getting the full program up and going. Alright, so this is the Russian peasant multiplication. Again, it is not really a recursive algorithm per se, but I'm using this algorithm to further my understanding of recursive algorithms because I don't really understand them, and this is how I really understand it, is by just changing, is that I saw the similarities. The way that I saw this is that the Russian peasant multiplication is very similar, can be adapted to a recursive algorithm, and I did it just like this. So I have 4 functions. One of them is the length function. So I'm going to plug in a number, say 18 right here. 18, if it's greater than or equal to 1, it's going to then go into this if statement, all right, where it's going to append that number to half. Now, this is a cool thing about lists, is that you can really have this list right here. It can be 1, 2, 3, 4, 5, 6, and then I can continue on. I can append to that list by adding more numbers. But in the circumstance of this algorithm, I want an empty list, which is what this signifies. This line right here is an empty list. That's me assigning an empty list to half. All right. Again, the cool thing about lists inside of Python is that you can make them as big as you want, as well as you can shrink them down as small as you want, all the way down to 0, which is what an empty list is. That is called a dynamic function. All right. It is a dynamic not function. It's called a dynamic data type, all right? And dynamic meaning it can adapt to its environment. And in this circumstance, I'm taking that empty list because I don't want anything inside of it. And I'm adding in everything for this function, which is half.append to add something to. So the .append method is the method used to add variables to an index of a list inside of Python. Now, the way that this is recursive is inside of this if statement, I'm also calling this function within itself. All right, that's what a recursive algorithm is calling. A recursive algorithm meaning I call the function within the function. All right, technically this can continue on forever and ever and ever. But the way that you break a recursive algorithm is by having some sort of Boolean statement at the beginning of it. All right. Most of the time, this is the statement that breaks the recursive algorithm, But in this circumstance, to me it makes more sense to have a Boolean statement like this if that keeps the recursive statement going. So for instance, let's use 18 right here. 18 is going to go into here. 18 is greater than or equal to 1, so I'm going to append it. I'm going to append that number. I'm going to append 18 to the beginning of half. Now the next line says return to length, so at the beginning, with math.floor. 18 divided by 2 is a even number. It gets down to 9. 9 divided by 2 is not an even number. It's 4.5. So that's why we use the math.floor, is because we want that 4.5 to get round down to 4. And it continues on and on and on until we hit 1 right here. All right? That's when the recursive statement ends. Afterwards, we're using the next function. We're again using a recursive statement. This time we're using the length of double. So the other list that's also empty, at this point it's empty, we're going to compare it to the length of half. By this point, half is fully populated, all right? And we're able to use the size of each list as a variable in itself. That is how we're able to keep this Boolean statement to be true, so that double continues to get populated until it reaches about the same size as half. But in the meantime, we're appending number into double. And then we're calling again MUL, and we're going to say number times 2, all right? So therefore, this one's going to be 89. I don't have a little thing at the end, but we'll change that up so that you can see the size at the end too. But afterwards, this is the combined function. This is where we're essentially we're creating a new function, a new variable called data, and we're turning it into a pandas data frame. The reason being is because we want to take half and double and zip them together. Hence the zip right here. Pandas has a really cool function that you can use with its data frames called zip. And that, like I said, it allows us to zip everything together. Now, the Russian peasant multiplication requires you to take out certain variables. Again, go check out this book if you want to learn more about this algorithm. I really do suggest it. It is a really cool book. All right, afterwards, we're essentially creating a Boolean statement within this data frame. All right, so data equals itself dot iloc, and then we're passing in data index of 0 modulus 2 equals 1. So for every index that has the modulus that can be modulus by 2 to equal 1, we're going to keep, and that is these dots means the whole column. All right, means the whole thing right there. We're then going to return the sum of the data.iloc, and this is just saying we want the whole column at row 1. All right, then it's the driver. So number equals input. What will the first number be? The reason why I am casting int right here is because the default variable of what input is always going to be a string. You can't really use that for this circumstance. Data coming in from that input I'm changing the data that's coming in from that input statement to get an int. This is the way that you get user interface in Python, all right? Is you call the input method. Again, number 2 is going to be the second number, so this number times this number is what we're going to get, all right? Again, it's the same thing. Int, I'm casting int for input, and what will the second number be? And then I'm passing in the number for length, passing in the number 2 for MUL, and then I'm printing the total value combined. And just so that all of you can see, it is 18 times 89 equals, so that's what's going to happen down here. And then I'm calling the driver function right here so that the whole program can get called. Another cool thing you can do with lists is you can say for I in half. All right, so let's say I is supposed to be 0. When we go into half and we find the value of index 0, whatever half is for index 0, I is going to then equal that, print it to the statement, and then it's going to continue on to 1. 1, it's going to find the index at half at value. It's going to find index of 1 it's going to find the value at index 1 for the list half, and then I is going to equal that, which is how I'm able to do this. All right, those are all the really cool things, but you can actually do a lot more. Like I could actually do for I in double. print I. Now let's run this and I'll show all of you. Again, remember, let's do Control R. What will the first number be? Let's say 18 and then 89. Alright, so 1602, 18 times 89 is 1602. So 18 divided by 2 is 9, divided by 4 is, 18 divided by 2 is 9. Divide 9 by 2 is going to be 4. 4 divided by 2 is 2. 2 divided by 2 is going to be 1. That first recursive statement is going to then become false, and it's going to continue on. Where we get 18, or we get 89. Divide that times 89 by 2. It is then going to get 178. The length of double is still less than or equal to half. All right, so therefore 178 times 2 is going to be 356. The length of double is still less than or equal to half. To the list half. So 356 times 2 is going to give me 712. Same thing that I just said. The length of double is still less than or equal to the length of list half. All right, and it's going to continue on until that recursive statement right here is false. Once that's false, it's going to continue on to combine, and that is where we're going to get the sum of that. So the sum of both those indexes, both those lists, is going to be 1602. Now, I'm not really using lists in here for these two. I'm just using straight up numbers. You can actually use values within a list to get the same thing. So why don't I do that real quick? I'm going to clean up this bottom stuff and I'm going to change up the values. So I'll catch you all in a sec when I finish that up. Alright, so I changed it up so that we're actually using the values of the list to actually recursively go through these numbers. Alright, and I'm doing that with actually two statements. Right here, return length of math.floor, the minimum value. So when I say min, I'm saying in the whole list array, I want the smallest value inside of that, and I want that to get pulled out, and I'm going to divide that number by 2. Alright, that is how I'm able to get the same exact thing as just using number itself. Alright, now same thing for max. I want the biggest value within double to get multiplied by 2, which is what I'm doing right here. Max double times 2. And then 18, see right here, 18 times 89 is 1602, and we still got 1602. And let's just run it for good measure real quick. 1889. All right, 1602. Why don't we try bigger numbers? Let's do 235 times 234. Alright, now let's run this, and we're going to use 2345 times 234. Alright. 2, 3, 4, 5, 2, 3, 4. And we got the same number. Russian peasant multiplication, also known as RPM, is something that it's actually an old algorithm based in like the medieval time. It didn't actually come from Russia, but you're able to use this to actually multiply very, very big numbers without actually having any knowledge of the multiplication table. However, the steps to get this algorithm is very, very long, and it is actually all highlighted in this book. This book is not this video is not sponsored by this book whatsoever. I just really think that this book is a really great resource for all of you to get and actually read through it, because it actually goes through a lot of very cool algorithms and it explains it in human sense. But if you're not there, there is another resource that you can have that it's going to be great for you as well, and that is Python Crash Course. This is also a really good resource to have as well. It really does go over all the possible uses for lists inside of this book. There's a lot more possibilities. There's a lot more use for lists. besides what I mentioned in this book, and mentioned in this code. And this book goes over it very well, and it, like I said, like this book as well, it is plain English. These books, I'm not sponsored by, this video is not sponsored by these books. However, if you do want to help support this channel, there are affiliate links down below to go get yourself one of these resources. And if reading is not your thing, there will be links to other YouTubers down below that explain lists in a lot more detail, like Tech with Tim and many other YouTubers. I'm gonna probably put like 2 or 3 down below, and those are the people that I use to learn Python myself. So go check out those links. They're really good. If you really enjoyed this video and you found value from this video, please consider hitting that like button. As well as, if you're not yet subscribed and you want to be part of the Islanders, then go ahead and press the subscription button as well as that bell icon. We are very close to 100 subscribers. Please join the Islanders. I'll see you. Bye.